Good morning, everyone. Next topic we'll see concurrent executions of transaction. So, what does here concurrent execution means? See, multiple transactions are allowed to run concurrently on the system, and we'll see some of the advantages of this concurrent execution. See, first advantage is increased processor and disk utilization. See, it is called as increased processor and disk utilization. Here it is increasing. That means a transaction consists of many steps. Some will be involving IO activities and other will be involving CPU activity. That is disk usage and CPU usage. So this both some transactions might be requiring CPU and some transactions will be requiring disk. So we'll allow them to run in parallel. All the instructions will allow them to run in parallel. So this will reduce so much of time. So it is called as increased processor and disk utilization. See, while a read write on behalf of one transaction is in progress on one disk, another transaction can be running in the CPU, while another disk may be executing a read write on behalf of a third instruction. So all of this increases the throughput of the system. That means the number of transactions executed in a given amount of time is called throughput. So maximum instructions we can cover by allowing some to use CPU and some to use disk. Like this we can reduce the time also, and all these can run in parallel and finish the work on time. So that is increased processor and disk utilization. Next advantage of concurrent execution is reduced average response time for transaction. See here, there will be a mix of transactions running on a system. Like some will be short and some will be short instructions and some will be long instruction. If a transaction will run serially, a short transaction may have to wait for a preceding long transaction to complete, which can lead to unpredictable delays in running a transaction. So if a transactions are operating on different parts of database, it is better to let them run concurrently, right? Sharing the CPU cycles and disk access among them. Concurrent execution reduces the unpredictable delay in running transactions also. Moreover, it is also reduces the average response time. The average time for a transaction to complete after it has been submitted. See, concurrency control schemes. So we'll be having some mechanism to achieve isolation. To see, we need concurrency in our transactions also. So for them we'll be maintaining some mechanism. Next we'll see some of the inconsistencies that we are going to face in performing the concurrent transaction. So first inconsistency is a lost update problem, that is also called as write-write conflict. See, this occurs when two transactions that access the same database item have their operations interleaved in a way that makes the value of the database incorrect. For this we'll see an example. See here, suppose your A is having 100 amount. So A is having 100 and A is equals to A plus 100 means you will get the new A value as 200 at this line. Next again you are performing read of A. At this particular point, R of A means, see, previous instruction in transaction T1, it is not updated anywhere. It is just perform some operation. Read of A means again it is going to take 100 not 200, because previous instruction we are not going to commit anywhere. Next A is equals to A plus 200 means it is going to take a result as 300. At this particular line we will get result as 300. So again when we jump to this instruction, see, first we are executing this, then coming to the second part, then third is this one. So here write of A means in T1 it has written A as 200. So it is taking A as 200. Whereas here write of A means it is taking 300. So here it is confused whether to consider A as 200 or 300. So this is an inconsistent problem that has occurred while doing a concurrent executions of transaction, whether A should be considered as 200 or 300. So this is your first inconsistent problem, that is lost update. So it has not updated the transaction A here nor in the second transaction. So it is reading its own values of A and A in transaction T1 and T2. Next we will see. Next inconsistency in concurrent execution is temporarily update or dirty read problem. It is well known by the term dirty read problem. So see, here it means that this occurs when one transaction updates a database item and then the transaction fails. It is updating and it fails there, but it updated the read by some other transactions. What it is telling here, we'll see with an example. See, if A is having again the value as 100, so next A is equals to A plus 200, it is taking new A value as 300. Then here we have written write of A, that means we are updating on the disk, like we are updating this value. So new A value is 300 now. Next read of A in the sequential transaction, what it is taking A value here as 300, because previously it is committed there. So A is equals to A plus 100 means now new A value is equals to 400 we are going to get. So again here also we are going to perform write of A, then we'll commit this. So once it is committed, A is equals to 400, commit means then we are going to update this on the disk. On the disk we are going to commit. Here we have performed write on the buffer at this point, but at the later stage we are going to commit on the disk. So A is 400, here A is 300. So which A is correct? Here also there is a like inconsistency. See here for this dirty read problem I can take one more example. Like suppose if like girl A and girl B are writing exam. So suppose two answers of girl like two answers B has been copied from A, and she'll go and submit her paper. Like B has copied from A two answers and she'll go and submit her paper. But this girl, what she is doing, A girl, at the later point of her exam, she is going to make the changes of those two answers, whatever she wrote previous answers, that she'll change to some other answers. Then she'll realize that those are wrong and she'll write new answers for that. So then she'll commit. Then that means when this girl, when she realizes after getting result, she has failed because of that two answers, and this girl has been passed because her answers were correct. So this is an inconsistent. See, this situation also might occur when you are performing any transactions. So this is one type, this is the dirty read problem transaction. That is, here you are getting 300 and here you are getting 400 as result. So this is an inconsistency problem, that is also called as dirty read problem or write to read conflict. Next we will see unpredictable read write conflict. This is the third type of inconsistent problem in concurrent execution. See, these are the different types of concurrent executions, but still we will be facing these four types of inconsistency whenever we are doing concurrent execution. So we are going to check all these types of inconsistency and then update our disk. So next we will see unpredictable read. Here what it is telling, see, if a transaction Ti reads an item value twice and item is changed by another transaction Tj in between the two read operation, hence Ti receives two different values of read operation. So what it is telling, see here, unpredictable read, that is, suppose again A is 100, it is performing read. Again here read of A means here it is again 100 itself. So new A value is equals to 200, it is performing some operation. So this it is writing. So write of A means A new value is 200. Again here read of A, actually it is should take this A value, that is A is equals to 100. It is performing two read operation. So unpredictable read it is doing again here. It has read previously and again after some delay again it is reading the same database. So this is also called as unpredictable read, because in between T2 has come and performed some transaction and left. Here again after a delay it is again reading. It has read something and left, and again after some time it is reading. So it will get same value here 100. But in middle some other transaction has updated and left. This is called as an unpredictable read or read-write conflict. Next we'll see incorrect summary. This is a fourth type of inconsistency occurring in our concurrent transaction, that is also called as right conflict. See here what it is saying. If a transaction, not this one, in this incorrect summary, if one transaction is calculating an here we'll see incorrect summary. See, if one transaction is calculating an aggregate summary, that is aggregate means we'll be using some aggregate functions, sum, average, min, max, like that. So like that functions on a number of records. If we are performing aggregate function on number of records by one transaction, while other function may be calculating some values before they are updated and others after they are updated, before and after, if it is happening like that. So what will happen now? See, in transaction T2 we are going to do sum is equals to 0. So we will set that sum value to 0 initially, and the read of A, what it is happening, read of A means suppose A is again 100. So sum is equals to 0 plus 100, we will get sum value is 100. Read of Y, if suppose Y is 200, then sum is equals to 100 plus 200, we will get here 300. Sum value is 300. But see here, what we are doing, we are not updating anywhere this sum. Here this sum value is not been updated anywhere. So it is called as incorrect information we are having, incorrect summary of information. Again, read of Y, we are going to read Y value as 200. So 200 plus 100, we are getting 300. But nowhere we are going to update it. So this type of example is called as an incorrect summary information. So these are the 4 type of inconsistency that will be occurring in our concurrent execution. So we have seen the advantages as well as the disadvantages. Thank you.